Here are the last 3 problems that I'm going to do with you guys. The reason I chose these 3 is because each one of them has something that I want to remind you of that you might run into when you guys are working. This first example, right? You're solving non-linear systems, meaning one or more of your variables is not raised to the first power. So if you look at this first question, you can't eliminate x's or y's. You can't get them to be exact opposites of each other because one is to the first power and the other is to the second power. So the easiest thing that we would do is we would use substitution. And I would say to take this 2x and move it over here so you're solving for y. So you have y equals negative 2x plus 1. You could also write it as 1 minus 2x. It's the same thing. But you're going to take this value and then plug it in. Whoops, sorry. Drew my arrow too far. Plug it in right here. So when you go to solve this, we have x squared plus, instead of y, you have negative 2x plus 1 quantity squared and then equals 10. So as we go to work through this, guys, you still have your x squared. When I have negative 2x plus 1 quantity squared, that means negative 2x plus 1 times negative 2x plus 1, and then I have equals 10. So the first thing we're going to do is we're going to FOIL. We're going to combine in the middle here. So I have x squared plus, when I FOIL this, negative 2x and negative 2x is positive 4x squared. Negative 2x and positive 1 is minus 2x. 1 and negative 2x is minus 2x. And 1 times 1 is 1. And then I still have my equals 10. So if we combine like terms, I have 1 x to the second plus 4x to the second gives me 5x squared. I have a negative 2x and a negative 2x gives me negative 4x. And then I have plus 1 and then equals 10. Well, we need to move that 10 to the other side. When I do that, I would subtract 10 from both sides. So that would give me minus 9 equals 0. And now we just have a regular quadratic that you guys have done 1,000 times. You guys can do this. I have a times c, so negative 45. What are the factors of negative 45? That multiply to give me negative 45, but when I add them together, I get a negative 4. What would this?
Negative 9 and positive 5.
Perfect. I have x minus 9 and x plus 5. At this point, you can stop and say, okay, negative 9 times 5 is negative 45. And then negative 9 plus 5 is negative 4. So we're good there. Now, in this case, guys, remember, my a term is not 1. So I have to divide both factors by 5. In a sense here, you're just factoring out the GCF. 9 divided by 5 is nothing pretty, so this just becomes your coefficient. It's 5x minus 9. And then 5 divided by 5 cancels out, gives you 1, so you have x plus 1 equals 0. So now when you solve each of these, you set them equal to 0. 5x minus 9 equals 0. You move 9 to the other side, becomes positive, and then divide by 5, so you have x equals 9/5. And here you have x equals negative 1. You can change 9/5 to a decimal in your calculator, which you're allowed to use. Remember, 9 divided by 5 is 1.8, so it's a terminating decimal. That's fine. I'm going to just go ahead and leave it as a fraction, because you guys can deal with fractions. I know you can. I'm going to plug in 9/5, and I'm going to plug in negative 1 and see what my y values are. Now, which equation you use to substitute back in to find, it's up to you. I always use the ones a little easier looking. So I'm going to use 2x plus y equals 1. 2x plus y equals 1. 2x plus y equals 1. So in this case, we have 2 times 9 over 5 plus y equals 1. Can't do anything but multiply the numerators here, so I have 18/5 plus y equals, what's another way I could write the whole number 1, but as that has a denominator of 5s? 1 whole is the same as what over 5? 5 over 5. Good, guys. Both of you, good job. I'm going to do that so it makes my math just a teeny bit easier, because here I have to subtract 18/5 from both sides. So in this case, y equals negative 13 over 5. So when I plugged in 9/5, I got out negative 13/5. And we can go back and check our answer using our calculators. Obviously, the one on the right-hand side is a little easier because you're just using the whole number. So you have 2 times negative 1 plus y equals 1. Negative 2 plus y equals 1. Add 2 to both sides. And y equals 3. So the ordered pair here is negative 1, comma, 3. And how do you know for sure that you're right? Go back in and plug it in. Questions. If your problem starts out with a fraction, your answer will be in fractions, so you might have to convert back to a fraction if you converted it to a decimal. You guys okay with that one? Yes, sir.
I have a question.
Sure.
I did, when I plugged in my x variables, I did the x squared plus y squared equals 10.
Mm-hmm.
And I got different answers from you.
Okay, what did you do? What did you plug in?
I plugged in negative 1
For
x squared plus y squared equals 10.
So, you mean at the beginning or like right here with your answer there?
Like I had I found my two x values.
Did you find both of these as your x values?
Y.
Okay, so you found, like you had negative 1 squared.
5 equal to x and the negative 1.
Okay, so negative 1 squared plus y squared equals 10, right?
Yeah.
So you got 1 plus y squared equals 10.
Yeah.
Subtract 1 from both sides, and you got y squared equals 9, right?
Yeah.
Take the square root, and you got plus minus 3, correct?
Yes.
Okay, totally fine. Jonathan, I'm glad that you're bringing this up. Because you found here that you had 1, 3, and then you also got negative 1, negative 3, right?
Yes.
If you plug this back in, does it work in both equations?
Oh, okay.
Right? So that's fine that you went about solving it that way. Perfectly fine. But that's why it's so very important to go back and check, because it has to work in both of them. So this one wouldn't. But that's fine that you did that. Just make sure you check your answers.
Yeah. Also for the I also plugged in x equal to 9 over 5.
Uh-huh.
And I got plus or minus 13.
Right.
So
Okay, well, so plus or minus 13, right, here?
yeah, it would be equal to y, like once I plugged it in.
Okay, hang on one second. Let me do it over here. When I get to something like this, I always try to go the easiest route. Like I would plug in to something that is to the first power, because then you don't have to worry about getting that plus or minus.
Okay.
Yeah. But you still can. You just have to go that extra step to check.
Okay.
So like in this one, I didn't mean to write all over the place. Sorry, guys. But in this one, there's not really much you can do other than let's just solve for a variable. I'm going to divide both sides by y. No, I'm not. I'm going to divide both sides by... Yeah, let's divide both sides by y. So we get just x equals. All right, I'm going to take that and plug it there. You can solve to where it says y equals. I'm just not, because then I have to distribute that negative 2. So I'd like to do as least amount as possible. So I have here 2 over y squared minus 2y squared equals 2. Remember, in this case, this 2 goes to the numerator and the denominator. So you have 4 over y squared minus 2y squared equals 2. Now I chose this problem for a reason, and you kind of just brought this up, Jonathan, here in a second. But how do I get rid of, I don't want to work with that denominator, so what do I have to do?
You can multiply every term by y squared.
Everything. You just got to be fair. So what you do to one side or one term, you got to do to everything. So when I distribute here, my y squareds cancel out, so I get 4. Y squared times y squared gives me 2y to the 4th And then y squared times 2 gives me 2y squared. So I see I have some sort of a quadratic. Got to move everything to one side. So I'm going to rewrite this as negative 2y to the fourth. When I move this y squared over, it becomes minus 2y squared plus 4 equals 0. What do you see, guys, that you can take out that they all have in common?
A negative 4 and a 2.
Well, I can't take out a negative 4, but I can take out a negative 2 from all of these, can I? Because we don't like to factor when we leave with a negative.
Yeah. I didn't take the negative out.
Okay, so take out that negative 2. You're left with y to the fourth. Negative divided by negative is a positive y squared. 4 divided by negative 2 gives me negative 2, and then I have equals 0. So we can factor a little more here. You have negative 2. What times what gives you y to the fourth?
Y squared.
Perfect. And then what times what is going to give me a negative 2 when I multiply, but a positive 1 when I add?
Plus 2 minus 1.
Perfect. Plus 2 minus 1. So now we're going to set each little piece equal to 0. So negative 2 equals 0. Y squared plus 2 equals 0. Y squared minus 1 equals 0. So look at this first statement. Is that a true statement ever, that negative 2 equals 0?
No, that's not true. So
No.
it can't be a solution.
Cross it out. So here, would you guys agree I'm going to move that 2 over, so this becomes y squared equals negative 2?
That's not possible either.
Why not?
Because it would be an imaginary number.
Good. If I take the square root here, this is going to be an imaginary number, so this cannot be a real solution. So in this case, that one doesn't work either. So at the beginning, you might look like you had 4 solutions, but you really don't have 4. You only have 2. Because I'm going to move this 1 over, and it's going to become y squared equals 1. We're going to take the square root of both sides. So y equals plus minus 1. Now, going back to the original problem, right, we're going to use y equals 1. We're going to use y equals negative 1. I, Jonathan, would suggest using this equation to plug back in, because then you don't have to worry about getting a plus or minus
Simple one,
as your
right?
answer. Right. If you plug it into the top one, then you have to worry about, oh, I could get plus or minus, and then you have to check all 4 rather than just 2. So I'm going to use xy equals 2.
Wait, I have a question. When you set this up to do your to plug in so you get your numbers, for your x values, you plug in the plus 1 and then the minus 1 separately, correct?
Yep. Right. Yeah. Separate them. Look at them as 2 completely different answers. So
And
here,
then once you
go ahead.
figure it out, then you put that in your coordinates, correct?
Correct.
That's coordinates?
Like here I have x times 1 equals 2. So x equals 2. That means my x value is 2. My y value is 1. Over here I'm plugging in negative 1. So x times negative 1 equals 2. Well, that's negative x equals 2. So divide both by negative 1, and x equals negative 2. So here this answer is negative 2, negative 1. Now be careful, guys. On the test, the answer choices might be, A might say 2, 1, and 2, negative 1. B might say 1, 2, and negative 2, negative 1. You know, C might say 2, 1, negative 2, negative 1. Do you see how similar those answers are?
Why is the test like that?
It's just the way that it works. It's not going to, the obvious answer is not going to just be jumping out at you. So it's going to make sure that you take one extra step to just make sure your signs are right. Okay, there's that one. And then that one. Oh, okay, look, it's C because both of those are together. Just making you pay, making you pay attention. That's super important. All right. Let's look at this next one. Okay, you're going to have a couple like these. And you'll have a couple that are already set up in back substitution and that you just have to solve. So this is taking care of those both kinds of problems. And you'll see what I'm talking about in a second. But I have what's called multivariable linear systems. They're all to the first power, but look, I have x, I have y's, and I have z's. So I know my answer is going to be in what's called an ordered triple. I'm going to have 3 answers. I'm going to have an x value, a y value, and a z value. Now, we went through some rules on how to solve this. First thing we need to do is get a system of equations where one of the equations has x, y, and z, the second equation has a y and a z, and the third equation has just a z. So in order to do that, I have to have my first equation to have a positive 1 coefficient of x. Is that right there what I circled in purple? The first equation. No, it's the second one. So I need to rewrite this as x plus 3y minus 4z equals negative 7. Now, it doesn't matter where you put the other two. The order doesn't matter. Just put one underneath. So I'm going to write 4x minus 2y plus 3z equals 1. And then we have 3x plus y plus 2z equals 5. All right, so what we're trying to get is our first equation to have three variables, x plus 3y minus 4z equals negative 7. And that first coefficient of x would be positive 1. We have it, we're good. Now, I cannot impress upon you enough the importance of being organized. I did this problem this morning 3 times, and I wrote positive 7 instead of negative 7. Kept getting the wrong answer. I was driving myself nuts. Take your time. All right, my second equation should have just a y and a z. So we're going to take 1 and 2, and we're going to cancel out our x's. So x plus 3y minus 4z equals negative 7. And then 4x minus 2y plus 3z equals 1. What am I going to multiply the top equation by? So that my x's will cancel out. Negative 4. Perfect. And it's going to be negative 4 to everything on both sides of the equal sign. So you have negative 4x. Negative and a positive is negative 12y. Negative and a negative is positive 16z. Negative times negative is positive 28. All these fuzzies in my mask are making me go crazy. Oh. All right, so cancel out our x's. I have negative 14y plus 19z equals 29. You guys with me on that? That's my second equation. Negative 14y plus 19z equals 29. Now my last equation right here should say z equals. So I've got to take now, I've got to do 2 steps. I have to take the first and the third. We're going to eliminate our x's, and then we're going to eliminate y's. X plus 3y minus 4z equals negative 7. 3x plus y plus 2z, that looks like a z, plus 2z equals 5. Now what am I going to multiply that top equation by so my x's will cancel out? What can I multiply? Negative 3. So here, 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 and here. So I have negative 3x. Negative and a positive is minus 9y plus 12z equals 21. X's cancel out. I have negative 8y plus 14z equals 26. Now I want this last equation up here, up here at the top, I want it to say z equals. So what do I do with these 2 equations right here that I just created? What do I do? We're going to combine them, right? Well, let's combine them. Negative 14y plus 19z equals 29. Negative 8y plus 14z equals 26. Now, you guys are allowed to use a calculator tomorrow. So if numbers get big or whatever, don't worry about it. You can use a calculator. When I look here, I need to cancel out the y's. Well, when I initially look at this, I'm like, I don't know. I don't know what 8 and 14 can make. So all I'm going to do is just multiply this bottom by 14 and the top by 8 because they're opposite. You know, like they'll just cancel each other out. But there's one more thing I have to do. What do I have to do? What am I missing that I need to multiply by?
A negative?
One of them has to be negative because right now both the 14 and the 8 are negative in our equation, in the green. So I'm just going to make the top one negative. It doesn't matter which one you do. But just take your calculators, guys. 8 times 14. I get
112.
Yep. So we have a positive 112y. 8 times 19 gives me negative 152z. And then 29 times 8. I get negative 232. Now I'm going to do the same thing with 14. 14 times, I know it's going to give me negative 112y, which is a good sign because we wanted our y's to cancel out. 14 times 14 is 196z. And then 26 times 14, 364. Now, I know at this point, some of you are going to be like, oh my gosh, these numbers are so big, there's no way this can be right. It's okay. Because when you just trust the process, trust what you're doing, my y's cancel out. If I have negative 152 plus 196, I get 44z equals negative 232 plus 364, and I get 132. What do I do at this point? Divide both sides by what? 44? And when we do that, guys, 132 divided by 44, z gives me 3. Is that a manageable answer? Yes. So I know in my ordered triple, z equals 3. So tomorrow on your test, some of your questions are going to start out just like this, where it says use back substitution, where you just take the z and now you plug it in here and then you find y, that sort of thing. But then there's going to be some that start out like this and say find the ordered triple. So in this case, we would just take our z value and plug it in here. I have negative 14y plus 19 times 3, that was z, equals 29. Negative 14y plus, what is this, 57, equals 29. Subtract 57 from both sides. You get negative 14y equals negative 28. When I divide by negative 14, what's y equal? 2. That's it. Just 2. So now that I have a y value and a z value, I can plug it into the very top equation and we can find out what our x equals. So you have x plus 3 times y, which is 2, minus 4 times z, which is 3, equals negative 7. X plus 6 minus 12 equals negative 7. X minus 6 equals negative 7. Well, add 6 to both sides. What's x going to be? Negative 1. And there's your ordered triple. The numbers were big and gross and ugly, but they weren't. It doesn't mean you did something wrong. And the way that you can check that is you go back to your very originals and you plug in all 3 values to all 3 equations. So 4 times negative 1 minus 2 times 2, right? Plus 3 times 3. And when I hit enter, I should get 1. And I do. So then I say, okay, let me check the bottom one, or the middle one. Negative 1 plus 3 times 2, because that was our y value, minus 4 times 3, because that's our z value. When I hit enter, I should get negative 7. And I do. And then the last one, 3 times negative 1 plus y is 2 plus 2 times 3. When I hit enter, I should get 5, and I do. So then I know that all of this work and everything, this is the correct answer. Questions? Talk to me. Long problem? Yeah. But you guys can handle it. What's up, bud?
Never mind. My math is probably wrong.
Okay. Where are you looking? What happened? Where are you looking? Like right here? This step right here. Do we have the same equations?
Yeah, no, I made a mistake in the math.
Okay. Okay. But do you understand the process?
Yeah,
Okay.
I understand the process. I just keep messing up on the math part.
That's okay. You just gotta take your time. You gotta take your time. They're not all gonna be long like this. You're gonna have some that start off, like I said, just like this. You just have to use back substitution and just plug in.
How many questions are there?
14 total.
Okay.
And it's going to be solving nonlinears, partial fraction decomposition, as well as this stuff. So
basically our quiz and this.
yes, correct. You'll have the whole class period. It's all multiple choice. But I will upload this right now.